So this whole time we're going to be in Unit 4.3. For today's notes, we are graphing sine and cosine. And the focus is on vertical shifts. Now, unfortunately, these examples do take a while to go through, so my ultimate goal was to do 3, but I'm going to be happy if we can get 2 in. So we'll see how far we're able to get. Now, as I said, you learned a lot in the video that you watched. Hopefully you wrote some of that down, took some notes over it. After a few of these, I really hope some of that information is going to solidify. It's going to make more sense. So we're just going to do examples. First example, we have y equals sine of x plus 2.
It worked for me.
Wonderful. Thank you. Printer was down this morning. That is a major, major inconvenience for me. First thing I want to clarify. I think I kind of made this a little obvious by how I wrote it, but I do want to make a point of this because it does come up every now and then. There are no parentheses to specify if it's sine of just x or sine of x plus 2. So in that case, do we assume it's sine of x or sine of x plus 2? Yes.
Sine of x.
Yes. So when there's no specific parentheses, you are only allowed to assume that the very next term goes with sine. Anything after that is considered separate. So if you're not given parentheses, it never hurts to write your own in just so you know what you're looking at. When you go to graph, you're always going to fill out the same list of information. Amplitude. Period. Interval, phase shift, vertical shift, and just for practice I will add domain and range. So before we fill out this information, let's talk about a few general things. So the general form of our sine equation, y equals a sine of bx plus c plus d. When you go to make the graph, you want to have a little image of what your graph should look like overall when it's finished. This will help you graph on the right track. So this is my little image. And I'm going to get in the habit of drawing this every time we graph one of these just so you know where we're heading with this. So a sine has a basic kind of template you have to follow. That little circle represents the origin. And when we start moving things around, that concept's going to get a little blurry, but for now that is the actual origin. So the sine graph, when it's graphed correctly, makes an S-curve. And it starts at the origin. From there, it follows a specific pattern. It's going to go up to its maximum, whatever that happens to be. And then it'll go down to what we call the midline. In this case, it is the x-axis, but it's the line that cuts your graph in half, horizontally speaking. Then it goes down to its minimum, and then back up to the midline. I'm going to sketch the curve. Try to keep it round. This is one complete S-curve. If we were to keep going, it would follow this exact same pattern if I go forwards or backwards. It's going to continue. So I always like to kind of top it off with an arrow just to demonstrate that. We'll get back to this when we're actually drawing the graph, but this is a good starting point. Let's fill in the information over here. Amplitude, you learned, is the absolute value of A. So if we compare the general equation to what we have, there is no number in A's spot, meaning it is 1. So A is equal to 1. That's the standard amplitude, so a typical amplitude, not a changed one. Period, there is a little formula. This was not mentioned in the video. 2 pi over b. In this case, if we go back up to our general, b again is the number in front, the letter number in front of the x. In this case, there is no number there, so it's 1. So we have 2 pi over 1, which is just 2 pi. This is considered the standard period length. Interval is the period over 4. So we have 2 pi over 4, which of course we will reduce 2 pi over 2. Phase shift, I'm going to go ahead and spoil this. These are vertical shift notes. So on all of the problems we're doing today, we are going to have no phase shift. So you're just going to write none. Vertical shift, this is actually the d value in the equation. So it's that number tacked on at the end, if there is one. In this case, we have plus 2. And you can also translate that as up to. And you could write either of those as your answer. Plus 2, up to, both, whatever makes more sense for you. Domain and range, typically we wait till it's graphed to answer these. We can actually go ahead and answer domain. If you can imagine this graph repeating itself over and over in both directions, hopefully you can agree with me, the domain is clearly negative to positive infinity. We don't need the graph to know that. The range, definitely wait till it's graphed because it really depends on the numbers in your equation. That changes quite a bit. So we'll come back to range at the end. All right, so let's make our graph. And you want to give yourself plenty of room just because you never quite know how far up or down you need to go, also left or right. It really depends on the equation. To get full credit on a graph, so specifically on a test or a quiz, you are required to graph 9 points. The first thing you want to handle is the shifts, if you have any. So we have a vertical shift. I'm going to go ahead and take care of that now, just because that kind of dictates what all we do with the intervals, the notches that we draw on the graph. So we have a shift of up 2. So we're going to move the origin, which also happens to be the starting point, up 2. So I'm going to draw that circle there. And this is where I'm actually going to start my first point. And again, I used a little circle for origin, but obviously we can agree that is not truly the origin. It has been moved. So just kind of keep that in mind. And I'm going to go ahead and I'm going to draw a dashed line through it. This is going to represent my midline, which normally sits on the x-axis, but now it's not. So this represents a vertical shift of +2. And again, this is also the midline. All right, the tedious part, labeling the x-axis. There's a very specific process to follow here. So, since we only have a vertical shift, the typical way you graph this is you have your starting point on the y-axis, and then you'll graph 4 points to the right and 4 points to the left. That's how you get 9 points total. That will meet your requirement. Yes?
I thought you went from like 0 to 360.
0 to 360. That was for the lab to kind of help you graph and get a visual of like what the graph looks like. We actually work exclusively in radians when we graph. Yeah.
Okay.
Yep. So we're going to go 4 to the right and 4 to the left. This is a standard way to graph, but it is not the only way to graph. So sometimes you can get a little more creative than that. So this is why we find the interval. This is how far apart each of these notches are. Our interval is pi over 2. So the first notch here is pi over 2. And this is where it might be helpful to write this as 1 pi over 2 instead of just pi over 2. Completely a personal choice. And because this is going to involve fractions and reducing, in my experience, it's been helpful when I've written out the unreduced fractions at the bottom so that students can keep track of what I'm doing. So I start with 1 pi over 2 because that's my interval number. And then from one notch to the next, it's a distance of 1 pi over 2. So I'm just going to go up by 1. The next notch is 2 pi over 2, which of course reduces to just pi. Next notch is 3 pi over 2, which does not reduce. And the last notch is 4 pi over 2, which reduces to 2 pi. So we've gone out 4 notches, 4 intervals. And if you remember, 4 intervals is equal to 1 period. There's a lot of connections to be made here, and you'll pick up on them as we go. But one thing to notice, you know you're on the right track when the last number in your interval matches the period. It should. That should be the end of that curve. So if I didn't end with 2 pi, I ended with something else, I either went too far or not far enough. So if I go 4 out, it should end with that period number. From here, finding the left side is extremely easy. It's the same numbers, but they're all negative. Negative pi over 2. Negative pi. Negative 3 pi over 2. And negative 2 pi. Alright, so now we can finally graph the points and draw the curve. This honestly is the most time-consuming part, is setting up the axes. Graphing doesn't take long. We're going to follow the pattern that I outlined for you earlier. We start at the origin, that little circle. Now we know it's not on the origin itself, it's up to. That's fine. This is where we're going to start our first point. And then we follow the pattern. So when we move to the right, the next interval is the maximum. So let's figure out our maximum. This is what the amplitude is for. It tells you how far up and down to go from max to min. So since our amplitude is 1, we're only going to go up 1 notch, and that's going to get us our max. Next interval, interval number 2, we land on the midline, which is this purple horizontal line I've drawn. So next notch is going to be on the midline itself. Third interval is the minimum. So we went up 1, so we'll go down 1 for our minimum. And then the fourth and final interval lands us back on the midline. Here we have the start of our S-curve. And if it helps, I'll go ahead and sketch the curve I have so far just to kind of get a visual. And then I'm not going to go any further to the right, so I'm just going to stop it with an arrow, but it would keep going up from there. So this is the pattern we've established, and if we kept going, it would just do it all over again. Going backwards, you have to be careful, especially with the sine curve. A lot of students assume it works like a mirror, so they would reflect these points over to get the left side. That's not how it works. It's a repeating pattern in the curve. So if you mirror it, it's not going to repeat. It's going to do the exact opposite. So you're going to essentially do this backwards. Instead of going up to the maximum for your first point, you're going to go down to the minimum, going to the left. And by the way, if you do this part incorrectly, you should be able to tell when you draw your full curve that it looks off. So it's a very easy mistake to catch if you make it. So we're going to go down to the minimum, then back up to the midline, then up to our maximum, and then back down to our midline. And when I draw the curve, you should be able to see how the pattern just repeats. Should just look like it flows and connects together. And as you can see, I have 9 points. I've got the starting point in the middle, and then I have 4 to the right, 4 to the left. That is how we end up with a completed graph. 2 full periods, 2 full curves. One small note to add is about the amplitude now that the thing is fully graphed. A equals 1, so go up 1 and down 1. It's the most straightforward way I can put it. Lastly, we have the range. So if you remember from the video, you were given a very straightforward rule to memorize. It's not necessary, but it's true. The range is the min to the max in brackets, since we have solid points here. Again, you don't have to have that memorized, but every little bit helps. So the minimum on our y-axis is 1, and the maximum is 3. As you can see, the range is very small, very specific. It's always going to be like that. That's everything that goes into making a graph. Like I said, it's a lot in the beginning, but this is the majority of what you need to know for the test. I'm going to add more things on top of it, but this is really the gist. Are there any specific questions I can answer about this specific graph? Basically any questions that I can't answer just by doing more examples. Okay, we're going to do another. This time we'll switch to a cosine graph. And I will go a bit faster since it's our second time through. Hopefully we'll finish this. We shall see. Our second example. Y equals 2 cosine of x minus 3. And let's go ahead and make our list. First we have amplitude. Second we have period. Third we have interval. Fourth is phase shift. Fifth is vertical shift. And then just for practice, domain and range. So to start, let's write the general form of the equation. Y equals a cosine of bx plus c plus d. And let's talk about the basic image of the cosine curve. So cosine has a U-shaped curve. The general pattern is the same, but how it starts is different. So that's really the differences between a sine versus a cosine graph. So we have our origin, still be in that circle. Now, the cosine curve does not start at the origin, it starts at the maximum above that origin. So whatever that max turns out to be, and then from there we have our 4 intervals. So we go max to midline to minimum, back to midline, and then back up to maximum. That's how we get that U shape. So what makes this unique is it starts at the max. And then continues the pattern from there. And once again, this is the midline. Once again, we'll come back to this more when we're actually making the graph, but it's nice to know where we're heading with it. All right, amplitude. This time we do have a number in A's spot. Absolute value of A is 2. Period, same formula, 2 pi over B. Two pi over, once again, our B here is just 1. So it's still going to be equal to 2 pi. Interval is the period over 4, which is 2 pi over 4, which again reduces to pi over 2. Once again, these problems are going to deal with only vertical shifts for now, so no phase shift. Vertical shift, that's our D value. D is at the end of the equation, it's that minus 3, which means we move down 3. And once again, domain on these curves is always negative to positive infinity, so I'll go ahead and fill that in. Range will be determined later. Questions on finding the information before we start the graph? All right. Once again, not sure how much room you're going to need. I know this one will require a bit more space, especially vertically speaking, so give yourself a little space there. First thing we deal with are the shifts. So we have a vertical shift of down 3. Now here's the thing, when you do this shift, you want it to affect specifically the origin. Don't move the rest of these points yet, especially that starting point. Move only the origin for now. So we're going to start with that circle on -3. And we're going to treat this kind of like our new x-axis, if you will. So this is a vertical shift of -3. So here's the good news. The previous problem had the exact same period and interval numbers. So that means the x-axis numbers are going to be exactly the same on this problem. So I don't have to think about that too hard. So I'm going to copy that left to right. I gave myself way too much graph here, but that's all right. So from the left, we've got -2 pi, -3 pi over 2, -pi, -pi over 2. On the right side, +2 pi, +pi, 3 pi over 2, and 2 pi. From here, we can actually get our points. So, when we start the graph, we start at the maximum above that open circle we graphed. So we're not going to start here, we're going to start at the max from there. The max is determined by the amplitude. Our amplitude is 2. So when we graph this, we're going to go up 2 from that open circle. And then we continue the pattern. So it's maximum, first interval, and if it helps, you can actually place tick marks on the midline you drew. If it helps with placement, that's fine. I do that sometimes. So this is on the midline now. Next interval, we go down to a minimum on the second interval. And I need more y-axis space, so I'm going to keep this going. So we went up 2 for the maximum. We're going to go down 2 for the minimum. I'm going to label some numbers here. Third interval, we go back up to the midline. And fourth interval, we go back up to the maximum of -1. That is the end of our first U-shaped curve. Reminder, the goal is to get 9 points. We have 5 currently, so we need 4 more to the left. Here's the beauty of the cosine curve. It does mirror itself. When you follow the pattern backwards, it's going to do the exact same thing. So you can cheat on that for this one, just don't do it on the sine curve. So if we go backwards, we're going to go down to the midline for the first interval, down to the minimum for the second interval, back up to the midline for the third interval, and finally back up to the maximum for the last interval. And then draw in your U shape. There we have 9 points, 2 complete curves, 2 full periods. Lastly, I'm going to quickly fill in the range, min to max, -5 to -1.